Hello, I'm Marc Wilson, and this is a simple milling project that we're going to manufacture today using Autodesk Fusion 360. The top surface of the part has about 1/8 of an inch of excess stock, so we're going to mill away about 100 thousandths of an inch of that with a 2-inch shell end mill using carbide inserts. This is a quick look at a 2-inch shell end mill. It's a great tool for roughing faces, but it doesn't leave a very good finish. The next step in the production process is to rough out the outer perimeter of the part. We're going to do this with a series of step downs. Each pass is actually taking off about 1/16 of an inch of stock. We'll leave 30 thousandths of an inch on each side to finish off later. The next step will be to rough out the pocket walls using that same 1/2 inch end mill. 30 thousandths of an inch will be left on the pocket walls to finish off later. 15 thousandths of an inch will now be semi-finished off of the pocket walls. A mic check will be done with an offset change if necessary before running the finish pass. The X pocket dimension from flat to flat will be measured using a telescoping gauge. After cleaning out the pocket really well to get that dimension with the telescoping gauge, the actual measurement will be used with an outside micrometer. It should mic 970 thousandths of an inch. If the micrometer reading is slightly big or small, we'll say 1/1000th of an inch or two, then a slight adjustment will be made to the tool's diameter wear offset before running the finished pass. And now for the finished pass. The final dimension from flat to flat in X should mic 1 inch on the button. 15 thousandths of an inch will now be milled off of the top face of the part. Once this is done, there will still be 15 thousandths of an inch of stock left on that face. The measurement from the top face of the part to the bottom of that pocket should equal 390 thousandths of an inch. Once the top face and the pocket are cleaned out really well, a 0 to 1 inch depth micrometer will be used to measure that depth. If the depth measurement would have been off by 1/1000th of an inch or two, the proper change would have been made to that tool's wear offset in Z before running this finished facing pass. It should now mic 375 thousandths of an inch. The counterbores will now be roughed out just like pockets. When this step is done, there will be 30 thousandths of an inch left on both the walls and the bottom for finishing. After the semi-finished pass, there should be 15 thousandths of an inch left on both the walls and the bottom to finish off on the next pass. Right now this should depth mic at 150 thousandths of an inch. After this finishing pass, the pocket depth should measure 165 thousandths of an inch. If the part is loosely toleranced, these last two steps really aren't necessary. A semi-finished pass will now be made around the outer perimeter of the part. 15 thousandths of an inch will be left on every side for the finishing pass in the next step. A mic check of the Y outer dimension on this part should equal 2.78 inches. If it's slightly big or small, an offset change will be made to that tool's wear offset before running the finished pass. After this finished pass is run, the final dimensions of that outer perimeter should be 2 3/4 inches by 3 3/4 inches. All 5 holes on the part will now be spot drilled. The 4 corner holes will be peck drilled with the twist drill all the way through to a diameter of 266 thousandths of an inch. The center hole will now be drilled out with a 23/32 of an inch twist drill with a little stock left on the ream in the next operation. This is a reamer. Its biggest advantage is that it makes a nice round hole. These are commonly used when something is going to be press fit into that hole. If done right, they also make a nice finish on the inside. And now the hole will be reamed to 3/4 of an inch. The RPM is about 100, and we're going to feed all the way in and all the way out slow. No rapid movements here. A telescoping gauge could also be used to check the final diameter of this hole, but we're going to use a 750 pin instead. This should go in easily, but a 751 pin should not. A ball gauge could also be used to make that final measurement instead of a pin or a telescoping gauge. This is a type of transfer that expands just like the telescoping gauge, and it's read with a 0 to 1 inch micrometer. Milling a 45-degree chamfer on all the sharp edges will be the last step in completing side A of this part. The The chamfer itself will be 0.010 of an inch, just enough to break an edge and make it look professional. There are a lot of different methods that could have been used to manufacture this side of the part, and the operations that actually were used here could have been ordered differently. Because the part is loosely toleranced, a few of those semi-finished passes that were done earlier could have been skipped or block deleted. And now it's time to flip over the part and do side B. There's roughly 1/4 of an inch of holding stock on here that needs to be milled off. Right now we're taking off the bulk of that with a 2-inch shell end mill. As stated earlier, these don't do a very good job finishing. Roughly 0.30 of an inch is going to be left on that face. A 0.15 of an inch pass will be made with a 1-inch high-speed steel end mill to semi-finish this face. The total part thickness should equal 890 of an inch. If that number is a little off, then a slight tweak will be made to that tool's respective Z-wear offset before running the finished pass. The final part thickness after this finished pass should equal 875 of an inch. After this 45-degree chamfer on all sharp edges of side B, the part will be completed. And here is an isometric view of both sides of the completed part. I'm Marc Tex Wilson. Thanks for watching.